Hello friends, in this video I will be talking about bit and byte. So bit is the smallest unit of storage, and a bit stores either 0 or 1. We all know about that. Everything in computer system is stored as 0 or 1. So byte is the collection of 8 bits. I can write it as 1 byte equals to 8 bits. For example, 010111010. So it must have 8 digits: 1, 2, 3, 4, 5, 6, 7, 8. All right. And 1 byte can store one character, like let's say capital A or small h or dollar, etc. So talking further, like we came to know that everything in a computer system is a bit. It is either 1 or 0, which is called a bit, and the collection of 8 bits is 1 byte. Now let us try to find out how many patterns are possible with n number of bits, because with 1 bit we can see that we can either get 0 or 1, which means 2 patterns. So let me make a small table quick. Okay, in this table we have number of bits and different patterns that are possible, and we are counting how many patterns. That makes our job easy. So let's say with 1 number of bit, with 2, with 3, with 4. With 1, the total number of patterns possible is either 0 or 1. So 2. I can either get 0 or can get 1. So with 2, it is 0 0 or 1 1. Or 1 0 or 0 1. So the total count is 4, right? So with 3, I think you already got the idea. It can either be 0 0 0 at minimum, comma 1 1 1 at maximum, and we'll fill all the other values, like 0 1 0 is possible, 1 0 1 is possible, 1 1 0 is possible, 0 1 1, 1 0 0, 0 0 1. So altogether, here is a comma in between. Altogether we have 1 2 3 4 5 6 7 8. Let's write it down, 8. So now we can just draw some kind of things out of here. So if we have 1 bit, then total count is 2. 2 patterns are possible, and this can either be written as 2 power 1. So if we have 2, then it's 4. 4 can be written as 2 to the power 2. In the same way, 3 can be written as 2 to the power 3. 8 can be written as 2 to the power 3. So whatever the number of bits we have to put it as a power. For 1 bit we are putting 2 to the power 1. For 2 bit we are using 2 to the power 2. For 3, 2 to the power 3. So for 4 we can say it's 2 to the power 4, which is called 16. So what conclusion we can draw is, if we add 1 bit in our left hand side, the number of patterns in right hand side will just double it. So for n number of bits, let's say we have dot and we get here n, the number of patterns possible would be 2 to the power n. It's very simple. 2 power n would be our count. If we have, are they in the same line? They are not. Okay, just make it over here. So if we have n number of bits, then total number of patterns possible is 2 to the power n. Now let us calculate the patterns for byte. We know that 1 byte equals to 8 bits, the same old formula, and patterns would be 2 power 8 equals to 256. So if we start with 0, the range would be 0 to 255. Simple. And yes, this range is used by ASCII, and in ASCII each number is stored in 1 byte, because this 0 is 1 byte, 1 is 1 byte, 2 is 1 byte, 3 is 1 byte. So it is the group of 8 bits. Like if we are saying A, or if we are writing A, then in ASCII it is 65. This 65 is 1 byte character. Then if we are writing B, then it is 66. Then like if we write something like pounds, then it would be the ASCII number of 35. And likewise at the rate would be 64. You can go through the chart of ASCII. I would also like to talk a little bit about the integer. So in integer we have short, int, long. So for short it is 16-bit, for integer it is 32-bit, for long it is 64. And if we had to calculate the pattern for this integer, then okay, so 16-bit is also known as how many bytes? 2, and because 16 divided by 8 is 2, and 32 is also known as 4, and 64 is known as 8. So let me write it. These are for bits and these are for bytes. And if we had to calculate the pattern PHTRN for, let's say for int, it would be 2 to the power number of bits. So bits for integer is 32, it would be 2 to the power 32, and we would get some huge number, or let us calculate it ourselves. What is it? Okay, it is 429,496,72,96. And like if we go for the range, it can store from 0 to the above limit. And if we are talking about the signed and unsigned, okay, if it is signed, then everything will be divided into half for positive and half for negative. And for the sign, okay, let's say its size would be starting with negative 214748368, and it will go up to 2147483,647. So talking a little bit about signed and unsigned, so unsigned can hold the larger positive value because there's no need to worry about negative side because it does not hold any negative value. For example, 0 to 255 is the unsigned. So unsigned means it only holds the positive, and signed means it holds both positive and negative. So unsigned uses the leading bit as the part of the value, while the signed one it uses the leftmost bit to identify if the number is positive or negative. Okay, the leftmost bit over here is minus, so it uses this to identify if it's positive or negative. And we know that signed integer can hold both positive and negative numbers. Like if we talk about this is the example of signed, and if we talk about where is our 0 to 255, okay, this is the example of unsigned. So guys, that's all for today. Thank you for watching my video and hope you like my channel. Subscribe it. Thank you. Have a good day.